So, hello everyone and welcome back. Today's gonna be maybe an hour, maybe two of soldering an OSSC, an open source scaler. To recap, this is one of these devices. It takes input from a retro console via SCART component or VGA cable and upscales and converts it and outputs it via HDMI. The entire process is from ordering PCB and components to packaging them into packets of 8 packets each with components and getting everything of that onto the main board, which is this board here. Last time we did all the major chips, the FPGA, converter, and most of the voltage regulators, which are here, which is package number 1 and package number 2. So today we're going to start with package number 3, and as you can see, I always have package issues because I never have enough bags, so I just stash it in with whatever it comes with. So we're going to start out with all of this and put it onto the corresponding places on the board. For that, we have a trusty little setup on my PC, which you can see here, which basically is a list of all the components on the board and the amount on the left. And this column here shows you which package everything is in, as well as a interactive bill of materials component which lights up the corresponding place on the PCB for each component that I'm looking for. So and from package 3 on, most of the components we're going to have are very small and teensy, and usually you use a soldering oven or a pick and place machine and then an oven to put this on the board, but we're going to be very, let's say, conservative and old school and do all of this manually. For this, we're gonna again need the trusty wand of swearing, which is this pointy end. Stick it into someone and he'll start to swear. Magic works every time. Works on yourself especially well, actually. So yeah, and that's basically it, what we're gonna do today, and that's where we'll get started. So I'm gonna put you into the same view I have, which is the scope view, and I'm going to give you the other view on the top left here. So I'm going to need this. Yeah, I don't think we're going to need this for now, so I'm just going to turn off the desk cam as well. So now number 1 on package 3 is the first LED, which is a red LED, and I'm going to take this and unpack it, and I'm going to have a tiny little set of reels here, which is basically this little piece here, and it comes on this strip, and that on there is an LED, and the little black dot in the middle is what actually produces light. Now we can just flip one of these out here onto the board, and I can just put this here with my tweezers, and then I can show you exactly what's going to happen. So so this is an LED, SMD size LED, which is going to be put on the board, and this is one of the view components that are so tiny, but they have a right way to put on the board and a wrong way to put on the board. And because there's so little space on these things, finding out the right direction isn't very simple, and it also differs from manufacturer to manufacturer, and there's multiple standards and whatnot, and in the end you're just gonna have to figure things out. For this specific type of LED, we can look at the back side which is hard enough in itself because actually flipping the thing over can be a pain in the ass, just like I'm demonstrating right now. But as you can see, there's this little T, and it basically tells you which side goes where. And also you can see there's the big notch and the small notch, and basically the small notch is the positive side. And if we look onto our board and go to the correct position on the board, luckily this is shown with a plus and a minus sign, so we know D1, which is a diode, and this is a light emitting diode, needs to go on here like this. And the same for the second light diode. Now this is a red one, and there's no way on earth to discern this from the red ones, which again is a major pain in the ass sometimes, but yeah, that's just the way things work. And now we're going to try to put this on there. Now for the first step of this, we're going to take our soldering iron and some solder and put this on to the positive side of the board. And we're just going to use a dab of this on here and a dab of this on here. Again, this is harder on camera than off camera, so excuse if something like doesn't look so nice, but it should get us there. It should get things working. And now we can just grab the LED. Try not to flip it off of the board because you're never going to find this again. And just hook it in there. There we go. And now we let it cool off just a teeny tiny bit and just put a tiny dab of solder on this side. And basically we're done with the first LED. So next we're going to take diode number 2, which is a green LED, or well, actually it's any color you would want to have, but the manual here says red and green, and we're going to use red and green. Some people prefer blue because blue light is cool, obviously, and there's usually not too much of an issue replacing these with one or the other. There we go. Just pack this back and grab, put it on the board, check the correct orientation, get the soldering iron, point it, place it, and grab the other side and just put it on there. Oh, this is all nice here. Touch it up a bit. And there, we're done. So if you do this the wrong way around, there's two chances. A, your colors are going to be wrong, or B, they're just not going to light up. And as you can see next to it, there's 2 resistors which are required, and depending on the color you use, you might want to change those resistor values, but in this case they're 330 ohms, and we're going to find them later in another package, I think. Yep, they're in package number 4, and we're going to add those after the fact. So, okay, next up are some, let's say, diodes. So we're going to take some filter diodes. Again, these come in tiny packages, and we're just going to find some place where we can look at these in peace. And basically, yeah, this is what they come in, how they look. I can rip this into pieces and try to get them out there. I'm not as good as a machine to do this, and also I have to try not to flip them off of my table or anything. So let's see, we get this done here. 1, 2, and we're gonna need 3 of these. you go. Put the real piece back into the bag, put the bag into the other bag, and we're basically ready to go. So we have D3, D4, and D5, and we can check where we have to go, and basically it's all on the other side of the board, and it's on the top left. If you look at the writing, it's on the top left, which is here, here, and all the way on the right side. There's the other one. So we're just gonna grab this, and again, it's the same procedure, and just takes a while to get used to this. You dab a little bit of solder on here. Let's get this in focus a bit better. You grab one of them. In this case, again, it's a diode, which means orientation is important. And as you can see, there's a line on this type, has a line marker on it. So we're gonna put this on here and then just use the other side and dab it. And there we go. Now, I'm going to repeat this for these two diodes, and there's one here, and I'm just going to do the second one as well while we're at it. And it's important to know that you don't do too many steps ahead of yourself or in parallel until you're used to building whatever device you're doing, because you're bound to forget something, and that's just not going to be fun debugging. So let's just go and grab that diode. There we go. And of course it's the wrong way around, so we've got to turn it around, grab it, and just flip it on there. So that's number one, and I almost flipped the other one off of my table, so I just grabbed that back. I'm going to go back here and just solder this back on. Yeah, weird angle camera at number one. And we're going to grab the other one. And again, almost flipped it off the table, which is always hilarious. And that's why I ordered them in way larger package sizes than you actually need them. So if it says 1 by 10, there we go. Got that one on there. And we're just gonna grab this here and put this here, and there we go. Now again, we have some tiny little blobs of solder that are stuck here. We're just gonna scrape them off and get rid of them before they somehow magically land on someplace between the board and between some pins, and that could really mess up with our electronics. So that makes 3 LEDs, which makes this next step complete. And now we're going to need 2 transistors. One is a BC847 and the other one is a BC857. They again come in reels. This time we don't have an orientation issue, we just have the issue that they look exactly the same, so we shouldn't mess up which one is which. And again, we can see on the placement tool where things are going to go, and the simplest way is either to know it ahead of time or search by the designator, and the designator is Q1 and Q2. And we have Q1, which is on this side of the board next to the SD card slot on the top middle, and I'm going to go there, and there we are, and we're going to get this into focus again, and I can show you back again. So this is where it goes, and this is how it's gonna look like, and we're gonna place this right here, and again it's dab a solder, grab the entire thing, get the right orientation. In this case there's only one direction this can go on, so we're pretty simple here, and we can just flip this on here, almost. There we go. We put this here, and we put this here and here. There we go. And that's Q1, which is the 847. And on the other side of the board, we have space for Q2, which is here, which is the 857 IC, which, as I said, looks exactly the same. And basically it uses the same process to get this on here. So we're gonna go again and get this turned around. Gonna go put this here, grab this, and shove it in there, and there we go. Sorry for the rotating of the board, but there's just no simpler way to do this actually with the setup I have. And 1 and 2, and that makes the second transistor on there ready for use. Yeah. So next is a larger number of items, and it's ferrite beads. And ferrite beads are usually for frequency filtering and noise filtering, and they go to quite a couple of places on these boards, and in our case there's going to be 6 of them, and all of them are going to go on this side of the board. And just let me sort this out for a second. Here we go. Okay, so we have ferrite beads. We need 6 of these. Again, this time they come in a little white reel. I'm just going to take 6, 2, 4, 6, snap this off, put the others back where they belong. And take one of these out here. It's always a little bit of a hassle because you can throw these all over the place, and again, you're never going to find these again once you've lost them. So we have ferrite beads, and let's put this on the board and put one here, and yeah, this is what they look like. And in this case, they don't have a special direction where they need to go. We're lucky enough we can just put them in any way we want. And in our case, if we switch to the desktop, I can show you that there's 6 that are required, and they go in different places on the board. And basically that's 3 on the right and 3 on the left side of this board. And important, it's FB 1, 2, 4, 5, 6, and 7. So we're going to skip FB number 3, which is a different type of ferrite bead, and it goes a different place. Luckily, we already have FB 1 and 2 on the board marked right here. So we can just go get the soldering iron out of its destination. Clean this off for a minute. Take this number 1 and number 2. Grab one of these and shove them in here. And while we're at it, we're just going to grab number 2 and also shove this in here. Now, depending on what technique you use to solder this, you're going to have these little top blotches of solder when pulling out the iron, which you don't have if you use a hot air machine. And yeah, basically that's what you have to live with, or you can rework everything and reflow everything with hot air later on and make them disappear or not. It's up to you. Like, you're not gonna put this into a production process like this, so it's not much of an issue because this is mostly for prototyping. So we have ferrite bead 1 and 2, so we're gonna skip number 3 and we're gonna look for number 4, which is right up here. And we can grab this, grab one, stick it on there, and take the other side. Heat, solder, happiness. Simple as that. And after we've done that, things are going to look like this. And we can move on to the next set of ferrite beads, which is on the other side of the board. Got number 7 here, number 6 here, and we're going to have number 5 up here. So again, we're going to grab this, and there's going to be a lot of this in the next 40 minutes or so, which is grab this, put solder on here, grab component with tweezers, not as easy as it sounds, heat up side of pad, put on, heat up, put solder on other side, component soldered on. That's number 5. There's number 7, and where do we put number 6? There's number 6. So we're gonna take ferrite bead number 6. Grab this, put this on here, wait for it to cool off for a tad. Other side, component and pad, add tiny bit of solder, done. move to next ferrite bead, which goes here, which goes on this, and gets soldered onto here, and then goes here. So that completes 6 ferrite beads. Now, as you can see, the ferrite bead right now here, this is a power regulator. And this is the output power regulator. There's a filter capacitor that goes here, and this is the ground plane, and this is the output, and it goes down there. And the ferrite bead again is between here and basically has some filtering purposes. And yeah, so the signal goes there, goes through there, onto the other side of the board, also goes up here, goes through here, goes into here, and continues off into that. So there's basically 2 types of filtering that happen here. Now that we have these 6 ferrite beads done, we're going to move into the realm of resistors. The first resistors is a 25 ohm resistor, which is R23. And let's see, where is R23 in my bag of bags? And it's a 25 ohm resistor. And here we have a 24.9 ohm resistor, which is close enough. And we're going to grab one of these, take the others, put them back into the bag, put the bag into the other bag. I think by now you're noticing a pattern here. And this time our 23 goes next to this connector which is a JTAG connector, and this resistor goes right here. So again, we're gonna take this resistor and this pad, take pad number 1, put solder on pad number 1, wrap the resistor with the tweezers, and grab this and put this right here. And next thing we're gonna do is put this here and solder the other side and be happy with it. With our 25 soldered on, we're gonna move on to the next resistors. This time we're gonna need 2, which are 47 ohms. And they are located, let's see, 47 ohms. Where do you go? Okay, they're in this little patch area here. And as you can see, we have one here, R34, which is these 2 pads, and we're gonna have one pretty close by, if I'm not mistaken. Yeah, okay, and the other one's gonna be right here. So I'm gonna grab 2 of these resistors. These are 47 ohms with a precision of 1%. I'm just going to put these on the table. And again, the process is the same. I'm going to grab this onto here. Clean the iron. Put some solder here. Grab one of these 47 ohm resistors. See. Again, these are resistors. They don't have a specific direction you put them on, but I prefer to put them on with their colored or written sign up. And in this case, because these are cheap ones, they don't have a specific written number on them, and we're going to get to that numbering scheme in a second with different value resistors, which we're going to go into. So we're going to grab this and put this one on here as well, and there we go. So next up, that makes 2 more resistors, 47 ohm. We're gonna need 10 75 ohm resistors, so this might take a while. Let's see, we're gonna need 10 75 ohm resistors, and I have 75 ohm resistors. These have a precision of 0.5% for what it matters, and I'm just gonna take a reel 2, 4, 6, 8, and 10 and just cut pieces of this reel off with the correct amount of resistors, which makes sure I have to recount them, and if something is missing, I basically get a warning because I still have pads open that need resistors, or I have a resistor left over, and that causes me to recheck the entire thing before I continue and mess up even more. So 75 ohm resistors, we have 10 of them, and that's 2 on the other side of the board and 8 on this side of the board. So I'm going to take 2 out of this little baggy rail bag here and grab the correct side of the board, and there we go. We have resistor number 1, which is R10, designation R10, which goes here right next to the converter, voltage regulator more, and we're gonna put this 750 ohm resistor on here. And again, it doesn't matter except for OCD which way around you put these on there, but I want to put this on there this direction. It's just so I can put the other one the other way around and people can shout at me for putting it on the wrong way around. So this resistor here has a designation on it. It's 750, and basically it doesn't mean 750 ohms, it means 75 ohms. 750 would be 751, 7,500 ohms would be 752, etc., etc. Basically, you can try to identify resistors by this value by using this convention, which sometimes works and actually sometimes doesn't, because if you look at the 25 ohm resistor we put on there, it says 39R, and if you look at these resistors we put on here, which are 47 ohms, they say nothing. So yeah, but okay, let's get the second resistor for this side of the board, which is in the middle of all of this. Actually, there's 2 here, R1 and R2, so I miscounted actually. It's 1, 2, 3 on this side, not 2 on this side. Okay, again, that's good to recheck this and put things where they belong, because if you don't put them where they belong and should go, things are gonna get ugly and messy. So we're gonna take one more of these, get them oriented the right way around, grab, place, heat, and not gonna go so well. That's always a little bit of an issue with stuff like this if you don't clean your tip correctly. Things like this happens, but it's not bad at all. You just grab the stuff off of the board and perhaps take a little bit of flux to get things cleaned up later on. But I'm gonna take this one, and I'm gonna take this one here, and go grab this again. There you go. That's number one. And let's grab this and give this here and put this on here, which is number two. So time to turn the board around, and let's see here, and boy, do we have a lot of resistors that go here, which is basically 3 of them. So I'm going to grab another 3 for this side here. And let's see what happens. Let's grab this and go here, and go here. Grab number 1, put number 1 here, and put number 2 right next to it. And put number 3 right next to that. And with a little bit of solder here, and here, and here, we can get this cleaned up a bit. And actually grab this off of here. And oh, hi Badumtsi, how's it going? And because this doesn't look so nice, we can always take a tiny huge amount of flux and just use the flux to clean this up. We're gonna go doom, and there we go. And as you can see, with flux, things are much nicer. And there we go. Yeah, I'm good too. Building stuff is always fun and also very soothing for my soul. So yeah, and I'm trying out doing all of this on camera, which is way harder, and also being on camera seems to drop my IQ by 120 points. But I think there's worse. Yeah, less important lesson: you can never ever have enough flux. Never ever. Flux is good. There you go. And we can put this on the other side. And there we go. Another one, which leaves us with 3 more to go. And if I'm correct, these 3 are 1, 2, and 3 up here. So we're gonna go number 1. Grab all of these out here. And put one of these here. And put this here. And we've got 2 more. Spin the board around. Spin the board around some more. Confuse all the viewers, but find the correct positions. Number 1 and number 2. Yeah, you're right. That actually is the wrong title. I'm gonna change that later on, but not now, I think. Because I'm almost through bag 3 out of 8, and that means I'm gonna take a break after putting on all of these tiny little pieces. And fun fact, so far I haven't thrown any of these off of the table for them to be sucked up by my vacuum robot. But I think the god of vacuum is going to demand a sacrifice soon. So we're gonna grab this, put this here. Come here. There you go. It doesn't want to go. Sometimes they just don't want to, which means we're gonna have to do them up a bit more. There we go. Yeah, but I kind of always remember it this way, and I have to learn to put the right title in the right thing. So, by the way, I think it's time for the size comparison once again. We have here this wonderful, beautiful 5-euro-cent piece, and yeah. So this is size comparison. If you've never done SMD soldering, this is the realm you're working in. And it is ill-advised to consume coffee or alcohol the night before because, yeah, like I'm 40 years old and this is about as steady as my hands can get with pressure on the tweezers. You know, if I relax my hand, it can get a bit better, but yeah. Do I know the Ben Heck Show? No, I don't know the Ben Heck Show. Should I know the Ben Heck Show? What is the Ben Heck Show? While we're at it, I'm gonna go and grab the next set of resistors, which are 100 ohm resistors, and see where they go. Let's check where all of this goes. The 100 ohm resistors are these resistors, and they go down here. Okay, let's see if I can size this up a bit. Oh well, not really worth it, but Huh. Okay, have to check this out. It's been noted. So let's see where these 100 ohm resistors go. They go on to the bottom right under the chip on the other side of the board, which is about here somewhere. Or not. Over here. There you go. R38 and R44. Exactly. So this goes here, and I'm gonna go back to the scope. He created first ever one-hand game controller. That sounds intriguing. Color me intrigued. And someone just dinged for something, and thanks a lot for dinging me. I don't know what the ding was for, because in this setup I sadly don't have any notifications on. And also my bot crashed again. Oh, okay, thanks for the follow then, if you're the lucky guy to ding me. Thanks a lot, it's much appreciated. So, okay, and we're gonna grab those 100 ohm resistors and put them, one goes here and one goes here. And oh wait, is this the wrong? Oh. And this is basically a perfect example. If you don't handle the bags, these come in correctly. Like if you drop the labeling off the bags or something goes wrong, you're stuck with stuff like this because they're so small that they don't really get noted anymore. And it's a pain to figure out what is what. But then this bird food, chicken food is so cheap in bulk that it's usually just better to throw it away and get some new stuff. He also hand soldered an Atari 2600. I actually had one of those when I was a little kid. And I saw one on a flea market a while back, but I didn't buy it because it probably spent the last decade in some barn and birds nested in it or something similar. And yeah, I don't want to spoil the memory of those consoles that I had when I was really little. So yeah, I didn't buy it, but there you go. So here's one of the things, like if it bugs you that your components are on there like this, the magic of hot air is always convenient. Now this is going to get noisy a bit, probably, but you can do all of this with a hot air gun like this, and once it heats up to temperature, you can just take this and point it at your components, and with a little bit of luck your components are gonna, let's see if this works, magically self-align into place. Here, they don't always magically self-align as shown here, so you can just help a bit and they drop into place. Surface tension of liquid solder is an awesome thing to do, but I prefer actually hand soldering it because it's for the actual skill improvement in soldering that I do this. And yeah, so this concludes bag number 3. And while I let this cool off for a second, I'm going to go back to my workbench place, and I'm going to show you how far we got. we got bag number 3. The PCB bags number 1 and 2, and we're still missing all of this. So yes, it's still a work in progress, but we're gonna grab, like, bags 7 and 8 are mostly mechanical parts, but we're gonna grab bag number 4, which is the next one we're gonna use, and throw these back into their box. And put away all of these because we're done with this. And we can continue with our work. And as you can see, this is how far we got so far. Let's see if this focuses. And the soldering may look awful under the microscope, but if you look at it like this, even without the board cleaned, it still looks like a rather semi-professionally built board. Of course, it's dirty and it's going to need some cleaning because of my tiny amount of flux that's been used on this so far. See the first video for that. But yeah, so now that we've got that part done, we can go here and I can just update my little file here because I've used some parts here. Whoops. So that makes it 36, that makes it 6, makes it 11, and that makes it 51. Basically, the line on the right, the 2 columns on the right is how much have I used and how much are left in stock for a specific part. And yeah, there you go. And there's some other magic that happens in the background for telling me that I'm running out of stock for specific parts and I have to rebuy them, or that there's well, the way I do it is I take these packages, these bags, and put them in a box for the specific devices I'm building. But that means that I usually have a bag in box number 1 for the OSSC with resistors, and also a bag in another box, maybe for the ST2SNES, with the exactly same parts. And this basically helps me schedule inventory and reorders and keep everything filled up in case I need something for repairs, or just for the fun of it, build yet another one of these little gadgets. Or if I've built something from scratch, I can salvage parts from the different boxes I have. And I can even lend out boxes. Like, you want to build an OSSC, here's the box, go have fun, here's the instruction, here's the video, go. Yeah. Alright, so we're gonna go back to this and we're gonna have bag number 4. Bag number 4 has mostly resistors, resistor, and resistors. So this is the resistor bag. And overall, we're gonna have about 30 parts from this, and we're gonna start out with number 1, I guess. Let's go back here, right on the scope, put all this here, and let's see where we go. First resistor, R12, is 220 ohms. Let's see, where does resistor 220 ohms go? It goes right there, which means have to move all the way on the board. There we go, that's R12. And what do you do, R12? Whoop. It's not what I intended to do. Take this here. Take R12, 220 ohm resistor. Put this in the bag, put the bag back into the other bag. Yeah. Maybe one day I'm gonna build a little robot that just handles all these bags and just hands me out whatever I need. So we're gonna take this 220 ohms resistor, and it says 220 ohms, 221, which the 1 stands for the amount of zeros to add after the other numbers, so it's 220 ohms, not 221 ohms. If the piece has a designation like this. And there we go. Put this on here. And that concludes another one. Next one is we need two 330 ohm resistors. I have to figure out what this one does. I actually don't know off the top of my head. We have these two resistors here, 330 ohms, and well, they're in line with these two LEDs. So they basically limit the flow of energy through the LEDs, or regulate their brightness if you so want. And we're going to need two of these, and they're going to be next to each other. And again, with resistors, it doesn't matter which direction they go on, except you have OCD and they have to be in the right direction of the writing that's on them. And there's going to be people who are going to tell you it's very important that they're always in the right direction, but no, not with this. Like, there are parts like the LEDs above here where it is important which direction they have, but not resistors. So we're going to grab one of these, and again, 330 ohms, not 331, because the one denotes add a 0 to all of this. And I'm going to take number 2, put this on here, and again, the problem with putting them on this way and minding the direction of the writing is basically you spend quite a lot of time trying to flip these tiny little pieces into the right alignment. You may or may not want to do that. Number 1. Number 2. There you go. So, and on one of these PCBs, and I must say that the OSSC PCB is very good for beginner to intermediate people doing this, has excellent designators and layout for starters, because you can really see what needs to go where, and it has the values that you put on there written on the board. Not every board has that, and not every board needs that. And yeah, there's just a lot of thought put into it, and also it's a comparatively simple board from a SMD point of view, by only having a top and a bottom layer and being rather strictly routed, so you can actually follow, like, this is okay, this is the ground plane, and this is minus, this is where ground connects, and this is where the LED goes, so power goes here through this transistor and disappears here to the other side of the board, and the same happens here for this LED. And now you could basically just turn this around and see where all of this goes and follow it through to wherever you want to see what happens, you know. And it's rather cool. and it helps you to recheck and gain confidence in placing all of this, which for some boards, if I can show you a similar board, if I show you this board doesn't have as much information on it, which makes it, and also incorrect information on it, because this is a different solder mask. And this board hasn't been, let's say, maintained as much. The files this board was created from hasn't been maintained as much as the OSSC board. And it's just like inconsistencies like this here, which makes it hard to read, and if you're not very experienced, can cause issues with everything. Yeah. So this is an SD to SNES board, by the way. Let's go do some commercial here. SD to SNES. This is a Revision F board manufactured by Crix. No, it's not. That's just what it says on solder mask. But yeah. And this is just a prototype board, so when I had this printed, I never changed this because this isn't a Revision F. Nope, it's not an ST3 SNES. This is actually the legit original board with a couple of changes that were never released by Ikari. So I did stuff myself. But back to the OSSC with a much more user-friendly layout. But in the end, I think the SD2SNES and the OSSC that are commercially sold are not hand soldered, so it really doesn't matter what it says on the board, except when you try to repair it, which requires you to have quite some extensive know-how anyways. So yeah, kind of a moot point. But the next resistor we have, R25, is a 698 ohm resistor with a precision of 0.5, which means it can go up or down 0.5% of its value. But it's important, it's a 698, it's not a 700 ohm resistor, it's a 698 ohm resistor. And we're gonna need one of them, and let's see where it goes. It goes next to the HDMI port, which conveniently is next to this ITC chip, which handles the HDMI port, and it goes right here to this pin here. So we're gonna go and put it where it belongs. And as you can see, if you'd be doing this alone at home, that's something that takes time and is a little bit puzzling. And here the designator says 82A, and is not 69 something or 698 or 70 something. So different designator because this is a different manufacturer which uses a different set of commands. So 698 ohms resistor done. Next we're gonna need 4 1 kilo ohm resistors, and you have 4 1 kilo ohm resistors right here. And conveniently they go all over the board, so a little bit of searching has to be done. And we're gonna grab let's get these out of here. 1 2 3 4. 4 1 kilo ohm resistors. And let's see where we place them. We're going to place them on dun 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 next to here, and the first one goes here. So R37 goes here. There you go. And the next one's gonna go right there. That's R40. And as you can see, this one has the designation 102, which means 10 plus 2 zeros, which means 1000 ohms. So here we go again. Place this right here. So that's 2 out of 4, and the other 2 go, one goes all the way up here, and that's right to the JTAG connector, which we're going to use later on to program the device once we get finished with all of this. And oops. Yep. And the last one goes here. Now, I committed and uploaded this interactive bomb model I showed you in a minute, specifically for the purpose of hand soldering and repairing these devices, because searching for all the places to put this is a pita, so to say. And oops. Again, if something like this happens and it's screwed up, you can try to fiddle with it, or in the end, if it really, really pains you, take some hot air, wait for it to heat up. In this case, it's just simple, put on the hot air, and while it warms up, already pointed at the board. This way it's not going to shock heat the board, but with a little bit of luck, after a couple of seconds and a little bit of wiggling, and sometimes a little bit of encouragement, the thing's gonna go and just flow into place. Yes, soldering is extremely satisfying, even if you do it like this, which is a little bit ugly because I only have a microscope that I can use that doesn't give me any depth perception, and because I have to sit in an unusual angle, everything looks less clean and not so nice, but yeah. A round in the ultrasonic cleaner after it's done is probably gonna make it nice and pretty in the end. So yeah, I'm not worrying too much, especially as this is just for showing how to do all of this stuff and not how to do it perfectly. I'm fine with it so far. So I wanted to show you the interactive bomb model again. So let's go there. And maybe I can just full screen this for a second. And again, this is actually made for repairs because it gives you a very nice schematic overview and lets you highlight all of the different parts, and it also lets you click on the parts and then shows you what it actually is, which is very interesting if you've knocked off some parts and need to replace stuff. But I'm basically using it as a guide to find out where to place stuff instead of searching the board for hours, because literally it takes you 5 minutes to find each one of these, and there's a couple of hundred pieces. It's just going to take ages. So I kind of just have this on the side, and it helps me immensely getting stuff done, while this Excel sheet helps me keep track of what is done, what needs to be done, where do I need to go next. And so I can just X off for every piece I build the corresponding part. And in the end, if I have all X's, there's a little green button that lights up, tells me you're done, you're ready to check everything, you didn't miss any parts. And ideally, by that time, I don't have any bags left with components to solder on, and all is good. And it's just a process because setting this up takes about as long as missing one part and not figuring out which one it is for half a day. So having a process like this is just going to immensely help you with your work. And I advise you do it for all the parts you have, for all the projects you have. Also teaches you about process management, project management, inventory management. So there's a ton of stuff you can learn just out of there as well. But now we're back to the 1.5 kilo ohm resistor, which we're gonna see where it goes. So basically I scroll down, select the 1.5 kilo ohm resistor, which tells me it goes on the top side of the board to the right of that chip, which means I can scroll up the scope, pick up the board, align the board correctly, and go to the chip, and go to the right side of the chip, and with a little bit of luck, there should be the right side of the board and the right side of the chip, and there should magically turn up a 1.5K signature for R11, which is exactly where I want to go. So we're gonna grab this again. Now this can get a bit fiddly because there's pins here, so I have to hold the iron a bit steeper, but it's not gonna change too much. And if I get onto the pins and put some solder on there by accident, it's not an issue. I just flux the entire thing and fix it, and it's not a problem. So we're gonna go there, put this here, and different manufacturer, different way of doing things. This one says 1501, which is 1500 ohms, which is 1.5 kilo ohms, which is okay, but shouldn't it be 152, or could it be 152, or yeah. Again, if you do this by hand, because of the size, it's going to leave these little notches here. And if I focus on this, you're going to see that this actually is quite large, and it isn't necessarily flat, but you can just apply a little bit of heat. And that's just to show you that you don't have to worry much about this, and with a little bit of luck, things are going to heat up, and you're going to see that things are gonna float into position. And sometimes it doesn't really want to go down, but yeah, then you can just use a little bit of force on it if you really want to do all of this. I usually don't care about it, but there's a lot of stuff you can just do here if you so feel inclined to do it. Next step is 3 resistors, 2.2 kilo ohms, and we're just gonna pick up these, and again, that's 3 of them. Put 3 of them onto the desk, pack them back up where they belong, grab all of this, and put it back into its corresponding bag. And let's see where they go. And have 2.2K resistors. They actually go right here. And all 3 of them go right here. Again, we have close encounter with the pins of the chip, which is also hand soldered if you've missed it. And we're just gonna put this here, here, and here. And put these on there. Now you can see this one is another manufacturer yet, with a different naming convention. This one is 2222, which would basically mean 22 plus 2 zeros. So the last 2 means 2 zeros are added. While the 1.5K resistors were 1501. And people do it differently, and sometimes the indicator, the amount of numbers on it show the level of precision, and sometimes it don't, and sometimes the color shows the level of precision, and sometimes it just doesn't matter. In the end, if in doubt, you'll have to measure it and knock these off the board anyways, just to figure out what happens. But I'm trying to be a nice person for whoever has to fix this, which is probably me if anything ever breaks on it. And that means I'm gonna be nice to my future self and try to just put this in the right position. So there we go. Next stop are 5 4.7 kilo ohm resistors, and I'm gonna try to speed this up a tiny bit, because 2 of these are gonna go on the board next to the HDMI connector. Nope. So 4.7 kilo ohms, 5 of them. Let's grab this, grab one side of this reel, flip off the 1, 2, 3, 4, 5 onto the desk, and let's put this back where it should go. 1 and 2 4.7 kilo ohm resistors. These are not numbered or don't have a designator on it, so be it. Take 1, 2, 3, 4. Just put all of this on there. There we go. That's 2. On the other 3 are on the other side of the board, and they're up here, right next to this IC. Have fun, Badumtsi. See you soon. This bag's almost over, and that's probably when I'm gonna quit for today anyways. So enjoy, and thanks for watching and being here and being a good sport. And we'll put this here. Put this here. Take the next 4.7 kilo ohms. Here and this here. And the last one's gonna be all the way over here. I'm gonna put this here. Well, that's a bit of blobby solder joint. Why are you so blobby? Where are you? Come here. There we go. Another piece done, and another bag that's completed, which leaves 2 bags for this setup, and we're gonna have 10 kilo ohm resistors, but this might take a while because we're gonna need 14 of them. So I'm gonna snip this off and count them off. That's 2, 4, 6, 8, 10, 12, 14. Snap this right off. Put the rest back into the bag. Put the bag in the bag. And just grab this. And put a couple of these onto my desk. And let's see, where do the 10Ks go? There's a couple of them up here, again, next to the JTAG connector. So we're gonna go check the JTAG connector, and there's 1, 2, 3, 4, 5, 6. 6 that go right here. Okay. So let's put this here. 1, 2, 3, 4, 5. Come on. 1, 2, 3, 4, and grab this and gonna go 5. I'm just gonna re-grab this one because it's a little bit off. Now we can just go and bop, bop, bop. Pop this on there as well. And we're going to take the 6th one and just place this here. So that's 6 done. And we're gonna go to the other side of the board, and the other side of the board we're gonna have 2 lonely 10Ks up here. So you can see this. That's one side, and that's the other side, and there's another one right here. And we can get these out here. We're just gonna place this right here. And here. That's another 2. And then we're gonna have another one down here. And things are gonna get a tiny bit crowded by now. Let's go grab this. Right here. And there we go. And that leaves us with 5 more to go, and 2 of which are gonna go right here. And we're gonna again just grab this one, grab this 2, and put the entire thing onto one side and onto the next side. Grab the lower edge of this. And just blob these onto here, and then have two more, which are right next to it, which are gonna go here and here. One more. And again, have this drop here and have this drop here. And there's one left, and that one is down here. We're gonna go and just blob this on here. And another one. And just go right there. And that's all our 10K resistors. And we can just take this piece of rail here and throw all of this back together. And for this bag, we're now left with 6 100K ohm resistors, which we're gonna grab out of here. And it's 2, 4, 6. And again, the process is simple. Figure out where they need to go, grab them. Let's see where they need to go. We have the 100K resistors, which all go onto 2 spots on the board, the left, bottom left, and top left of the bottom side of the board, which basically is right here and right down here. So this shouldn't take too long. We're going to rotate the board, orientate ourselves, grab 2 of these, number 1, number 2, spill all of the resistors onto the desk. Try not to sneeze at them because that would make them go bye-bye. Nope. And try to place them. Again, designator 10 and 4, so that's 10, 100, 1,000, 10,000, 100,000 ohms, which is 100 kilo ohms. That's 10 plus 4 zeros added to it. So this doesn't look as nice as I want it to look. Well, definitely not. So decent amount of flux, grab, make look much better. Magic of good flux use. If you're wondering, yes, there is flux in the solder I'm using as well, but it's a bit cheaper, so it doesn't flow as good. Yeah, but since I'm going to rework this board anyways once it's complete, to touch it up a little bit, it's not that important to actually be that clean right now, because there's going to be a cleaning step involved once everything's done. We've got 4 more to finish our bag here. There's 1. There's 2. Well, that didn't work as intended, so remove, try again. That's better. There you go again. And we have another one that we're gonna grab off the desk, and there we go. Now just a quick dab 1, dab 2, dab 3, and dab 4. So they're all where they're supposed to go. 1, 2, 3, 4, 5, 6, and we can take those little specks of solder and take them off the board, because they can be a pain in the ass. And especially if you start cleaning the board with alcohol, because once you're finished you should clean everything with alcohol. These little specks and these little flakes of solder can get stuck between these pins. For example, they can get stuck between one of these pins here, and that's enough to short them, and that's going to give you a crappy picture, or even short circuit the power rail to ground, which is going to cause all kind of troubles. And yeah, the next step, now that the 4th bag is done, 4 of 8, we're halfway there, is going to be clean off the worst dirt off of the board. And then I'm going to take a break for today. I'm gonna go get something to eat. So what basically is now gonna happen is I'm gonna grab my trusty my trusty 99.9% isopropanol alcohol, and even more trusty Q-tips, and clean off the worst flux residue I have on the board. And I can show you this, maybe just show you here. That's not a problem of just grabbing this stuff, trying to get in between, and just wiping off the board generously with alcohol. The alcohol is gonna dry off, and basically leave you with a clean board. This is mostly because when you're handling this board, you're gonna get all of this flux residue on your fingers, and it's not the healthiest of things in the world. That's one side of it, and the other side of it is that basically it makes your fingers sticky, and that can lead to all kind of problems when handling small parts and whatnot. And another advantage of going over all of this with this alcohol is that if you haven't soldered on a piece correctly, you have a chance of knocking it off right now, here and there, and that's just basically gonna show you that you did something wrong right here and there. And yeah, now, depending on how confident you are with what work you did, now is a good time to just go over the board again, check for unfixed solder joints, solder breaks, bridging, or any other issues you might have. This is still all a bit wet because it's going to take a second for all this to dry off, and you can see there's all kind of schmuck going on here, and you can just clean this off. Yeah, you can have, this is one of these solder blobs here, and you can see it on the top left, this little speck here. If I take this and during the cleaning process move it over, magically move it to the other side of the board, and if this would just happen to land here, that'd be a perfect short of these two pins, and as these are signal pins, this would short the signals between these pins and cause all kind of shenanigans. So grab it, throw it away, far away, and be happy with it. So that concludes bag number 4, and basically today's work. As I said, we're halfway there. We're almost done with all of the major components, and we're done with most of the passive components. The next bag is going to be a set of capacitors, mostly filter capacitors, which I'm going to explain then. After that, bag number 6 is going to be a couple of fuses, quartzes, clamping diodes, and then bag number 7 is going to be all of the connectors, and bag 8 is going to be mechanical stuff, and we're going to print a casing for this. You can see a 3D printed case here, and yeah, once we've got that done, we're going to do final checks on it, power it up, and I'm going to show you how to initially program it and give it the capability to self-update via SD card, and then we're going to take the new one for a spin, and we're going to look at setup and tinkering with it, because I have looked at the firmware of this a bit, and I've found a few little quirks and funny things to do. And that's another episode we're going to do, where we're going to look at all of this. And finally, we're going to go through final checks and debugging and getting this ready for fixing in case of errors and common mistakes that are made. Yeah, and that's basically it for today. And I'm probably going to continue with this on Saturday, and around 7 p.m. Central European Summertime. And I'm estimating it's going to be another 2 to 3 hours to get this done, which would put us for a total build time of about 8 hours for one, which isn't bad considering that it's done on camera. And yeah, you can greatly improve the speed if you're not talking all the time. And yeah, well, I hope you learned something. I hope you had fun. I hope you enjoyed. If you have any questions, feel free to drop me a message on Twitch or on Discord, or just get in touch. There's a great section on the OSSC on the Video Game Perfection forums, where also Marks, the creator, is online sometimes, and where you can buy your do-it-yourself kits. Or if you have any questions about ordering parts or the PCB, feel free to contact me. So far, that's it for tonight. Have fun and see you soon. And for the courtesy, we're now gonna go and raid another science and technology guy. His name's Oh Bother. I think he's working on programming some Twitch stuff today, so let's see what he does. Have fun. See you soon.